All right, chemistry. So for the second titration lab we're going to do, we're going to add a lot more lab equipment. We're going to do some digital data taking and things like that. So before I actually do the experiment, I want to run over with you the new equipment that we're going to be adding. So the first thing is, instead of using a pH indicator, we're going to be using our pH probe. We've used this before, right? It's like a fancy thermometer looking thing that tells us what the pH of a solution is. Okay, so instead of determining when it's neutral by the color change of the indicator, we're going to be telling when it's neutral by just reading the pH, right? It's pretty simple. Another thing that we're adding is automated stirring using this magnetic stirrer right here. Hopefully you can see that on the video, right? This thing right here is a little tiny magnet. We put another magnet underneath the beaker like this and spin it so that this thing will constantly mix the solution for us. That gets rid of our need to swirl. So that's the pH part of the new equipment. The other part of the new equipment is this thing. It's called a drop counter. All right. So the burette's jet tip is going to stick right in here, which is a sensor, right? And it's going to count every single drop that passes through, and it's going to convert the number of drops to the volume that we've added. So we don't have to mark the beginning and end of the titration here, because we will be counting the volume in real time as we add it with this drop counter, right? So with both of these things together, all of the data that we'll take will be digital. That's why you can see the LabQuest screen behind me. We're going to be plotting this in real time. I'm going to be putting the data that we take into OneNote for you guys, and you're going to be required to graph that data and put it into a sheet in OneNote. All right? All right, class. Good luck. So in this experiment, we're going to be titrating this distilled white vinegar here. It's just from the grocery store. You can see I already have my pH probe over there. It's off screen right now, but you can see the pH reading here of 2.73. That's going to be important for us. But our goal is to determine three things from this lab. We want to know what the hydrogen ion concentration inside this vinegar is. You can do that from the pH by plugging it into this formula right here and finding our hydrogen ion concentration. The second thing that we're going to do, part two, will be to determine the concentration of acetic acid in vinegar. All right, so how do we do that? We're going to use our titration setup here. We're going to take our 2 molar NaOH, which is our same base we used in the last titration. All right, and we're going to add it until we neutralize this acetic acid right here. We have 150 milliliters of vinegar, which is acetic acid, down in our beaker below. Okay, so once we know the acetic acid concentration, and we've already determined the hydrogen ion concentration, we can come up with the percent ionization. All right, so that's the goal from this lab. Our class, it's time to go ahead and do our titration. I'm going to go up here to the top and hit collect, right? And it's going to sit here waiting to take data. It's not taking any data right now, because if you look at our x-axis, it's waiting for the volume, right? And the volume, like we talked about in the very beginning, is going to not come from reading the burette this time. It's going to come from counting the drops that pass by the sensor. Okay, so it's waiting, right? It's mixing. Hopefully you can hear this automatic stir here, this magnetic stir. I'll turn it back on so you can kind of get a feel for how it works. All right, there we go. It's constantly mixing the solution down there at the bottom. It's waiting for data now. We're going to go ahead and we're going to start dropping. We've got to do this slowly and hope that it counts our drops. Let's see. There we go. Okay. Hopefully you can see here, it's now counting our drops and it's converting them to milliliters. It's also graphing our data right here. So you can see it's kind of coming up like this, right? We're at a pH of about 3.2, and it's measuring the volume that we added down here below. So we're just going to watch this thing go, and when it finishes, we'll talk about what the graph means for us, okay? still not neutral, guys. It's still kind of working its way up here. I'm probably going to cut the video into different pieces so that you don't have to sit here and watch this thing do this the whole time, speed it up. But we're about halfway done. And I'm going to go ahead while this is going and just add a little bit more sodium hydroxide here so we don't run out. There we go. Good. Alright, so it should kind of keep doing its thing here. Stay tuned. We're going to keep building this titration curve. All right, class, so you can see here, we did our titration curve. The pH came up slowly, kind of leveled out for a long time, and then it reached kind of this inflection point right here where it shot straight up and went from, right, this is 7 right here, so it went from neutral up to base, right? So this line is a special point in a titration curve. Right in the middle of this is what we call the end point of the titration, or the equivalence point, right? So right here, you're going to draw a line down, right? It looks to me, you might be able to see it on the screen, you'll be able to see it on your graph for sure, that it's a little over 50, right, to reach this equivalence point. So I'm just going to let this graph kind of level off so we get kind of a straight line up here at the top. So this is the last part of the video here. We can see our titration curve, right? Down here at the bottom, this is our volume of NaOH, 2 molar that we added. Right? That's our volume on our x-axis. When you make your graph, you need to make sure that's labeled. Right? And here, I'm going to mark with a star. This is what we call the endpoint. Right? It's that inflection point right on that vertical part. If we draw a line straight down like this, right, we find, let me erase this so we can see, right, this is 50 and this is 60, right? We can actually use our cursor here to get right on that line there, and it looks to me like this reading here is about 53.6 milliliters of our base right there, okay? So this is the stuff, you need to have all of this right here labeled, including the pH on your graph. This is the major part of the lab grade. We'll be having a titration curve like this, okay? Don't forget the first part of the lab as well. We had 150 milliliters of acetic acid. I'm going to go ahead and show you how we do the shortcut to determine the concentration. All right, students, so we have our data here from our titration experiment. I'm going to show you the quick, fast, shortcut way to determine the concentration of an unknown acid when we do our titration, right? I kept this mark on the board here. This is what was the endpoint, which we found this volume of this base required to neutralize this volume of an unknown acid. Right, this formula I'm going to write on the board should look somewhat familiar, and you can think about why that might be. It looks like this. The molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. This is the last equation for acids and bases that we'll probably have, and it's a nice, easy one. Right? All you do is plug our numbers in here and solve for the molarity of the acid here. That will give you the acetic acid concentration and allow you to complete the lab. Good luck. I'm here if you have any questions.